Hello, it's Scummanly here with more Shenzhen IO. Next project is a cryptocurrency deposit terminal. We've partnered with a major financial services company to create a cryptocurrency deposit terminal, basically Bitcoin. Basically, they take money and they will convert it. They will give you an account with digital, fake, imaginary currency, depending upon your point of view. So we have a card reader, which is XBus. We have network. We have 3 cash connections, and before I even look at what's going to happen, I know I'm going to do that, right? You just know what's going to happen. So user initializes transaction by inserting their account card. It'll get 8 digits from here, then inserts money, which means pulses here. The user finalizes by ejecting their card, and then it'll send a -1 here. So digits come in, then we get 50, 20, 100, 100. And then when we send a -1, we get lots of numbers followed by 270. So I suspect that we're going to use the memory. Let's build this in 2 parts. So I'm going to build this, let me just think the best way to do this. I'm going to start with an MC6000. Oh, let's just do that, because we'll probably have to talk to this thing. We'll probably have to talk to the card reader, actually. We will talk to this card reader. And then this will talk to the network. Now I'm just wondering whether I want to have this read in the stuff and then pass over control to something else, which then completes the transaction. Or you know what? Let's actually, here's an idea. Here is my cunning idea. I am gonna read this here. And then this obviously needs an X1. And I can just send a pulse across this. Okay, so this is the layout. I'm just thinking to see whether this will make sense. So what we'll have is this thing will read in the digits, and it'll store the data in here. Then when... Now it'll signal this thing to say, hey, start counting money. And then this thing will count up money, and when this is done, this will signal again, like, stop counting money, and then this thing will write out the data to the memory, and then this thing will read it back across the thing and send it across the network. Okay, so let's start reading across the network. So it's non-blocking XBus, so we need to start every single loop with move X1 into the DAT register, and what I'm going to do is we're going to do a TCP test compare DAT against -1, and if it's greater than, super easy, if it's greater than, we just move the DAT register into... Now, do we need to initialize this? Let's just assume they're only going to come in a pack, so let's move it to X2, which is into the memory, and jump back to the start. ST. Jump to start. If it is less than that, then that's -99, so we need to jump to the sleep. So we'll have a sleep function somewhere, which will say sleep, means don't do anything. Finally, we have -1. And -1 will need to signal this. Wait a second. This thing should actually signal P0 to tell it to start counting. Unless I just cheat. I could just cheat, right? This is the thing. I don't know if there's any validation stuff that will break this, but all I need to do is start counting the money as it comes in and then apply it to whatever account is valid when that is correct. So all we're going to do, okay, move 100 into P0, or, yeah, move 100 into P0 for a second, and then we'll send this data across the network. But I need to figure out how to do that. So actually, and also, for sending data across the network, we'll move 0 into X3, move... Okay, so you know what? I'm going to use this bottom one. We'll write the number into the thing here. Now, how many digits? We have an 8-digit account number, so we will move... Oh, no, you know what? That's fine. We don't even need to count these things. We just need to reset this. So, brilliant, brilliant, brilliant. So all we're going to do is loop, and we're going to move x2, which is the data, into x0, and then we're going to test if this is test x3 if the address is equal to 9. If so, we're done. Or actually, if it's less than 9, and then we'll jump back to loop. Right, so this thing will be handling my increment nice and easily. Once we're complete, we move 0 into the address position. We're going to reset the address, and that's, I think that's us. I think that's us. So let's actually do this. We send a signal across here, but we're just not going to care. So first thing we're going to do is check. Actually, maybe we should do this, right? So test if equal to P0 is equal to 100. If so, then 0 out the accumulator. Move 0 into the accumulator, right? Then we're going to do a test if equals, or test. Okay, so yeah, we can do various things here. We're going to test one after the other. TEQ cache. I'm just trying to think of the best way to do this. Things, music is playing in my head. Also, I need to connect these things to make it work. So test if equals, and I'm gonna remember, is this thing, this is P2 is the one that's associated with 100, right? So if x1, test if x1 is 100, then move, or sorry, add 100, and you could do test equal x1 as 10, add 50, and test equal x1 1, add 20, right? I can probably make that logic more compact, but let's just follow this thing to its logical conclusion. Then, once we've done this, if we've done any of these, if we've modified anything, we need to move, we need to set the address on the address line, which is x3, so move 9, oh wait a second, 8, because we start at 0, move 8 onto x3, and then move the accumulator into D1, wait a sec. Oh, not D1. It's x2. And then that's that there. And then sleep. Is this it? That's surely not correct. Let's see how this works. Ah, there's a problem. Okay, so there's a problem there. Okay, so advance. This worked fine. We send that data. Oh! I forgot to reset this thing here. So we send out this, right? And then we reset the value, but then this thing keeps resetting the value. So I move 100 here, move 0 to x3, send all the data, I've done all my loops, and then I should move 0 to P0. So I reset the pulse after all that time. Let's try that. Simulate. Oh, and it's still failing because you know what? We're sending this pulse out very, very quickly. And you know what? Why am I doing that? I can just do a gen pulse. Okay. Yeah, let's do this. Here. Instead of moving to, I'll generate a pulse. Gen on P0, 1, 0. And then fall through, and hopefully we don't immediately get another function call, another thing, otherwise we could have trouble. Simulate! Excellent, excellent, excellent. Lots of excellence. There's all the cryptocurrency, all the bitcoins in the world, and power usage 948 in the middle. Could be better. Production cost is pretty good. Lines of code is definitely erring on the side of pretty darn excellent. So maybe I can improve that, but I think I'm going to stick with this for now. Oh, come out of the continue editing. Let's see what happens. We've partnered. Okay, great. I think we can really catch the wave with this one. Cryptocurrencies are really surging in property because of people that like cryptocurrencies. Thanks to recent market fluctuations, it seems that even people who used to work primarily with cash are giving up and looking for an easy way to convert their money to digital these days. Easy? Cryptocurrencies are not what I would call easy. I wish I had my own currency. It would be nice to use a medium of exchange that you can manipulate any time you like. Ha! 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 Oh, Carl, you're so funny. 55% of homes are infected with viruses. No. Wow. Homes infected with viruses or malware can lead to spoiled or poisoned food, water damage or flood damage, even kitchen and electrical fires. That's because of the Internet of Things, which is short for the Internet of Things that should never be connected to the Internet. Okay, let's take a look at the pollution sensing window. I'm working on a smart window that reacts to particulate matter in the air. I need a controller that allows us to close the window when the level is too high and opens it again when the level is lower. Okay, so let's get this to designing. So, pollution sensing smart window. Sensor is a simple input connected to an air pollution sensor. Window is a simple output connected to a motor that opens and closes a sliding window. The window should be closed when the average sensor reading for the 8 most recent time units is greater than or equal to 50. And I don't know, this may sound... I'm sorry, I'm laughing here. This is hilarious. This is really funny. It's a nerd thing. So this algorithm where you have like an average, a running average over time, is called a sliding window. And so we're going to use a sliding window algorithm to control a sliding window. And this is so nerdy, I'm sorry, but I'm beaming from ear to ear because I find it quite amusing. So I think we're gonna need memory because we need to keep track of 8 data points, and we're gonna need logic attached to that, right? We'll connect to the center, connect to the window, and then the question is, can I fit the code into this small space? So I need to add up all of these, and so wait, it says greater than or equal to 50. So actually, multiply that by 8, and the value is 400. So every time section, I'm going to read in the value into the thing, and then add that into the accumulator, and then subtract the next one. Okay, so let's just try this. So, okay, do I move this into... Yeah, we'll move this into the DAT, right? Move P0. Oh wait, no, because it's a simple sensor, we don't even need to do that, right? So what we'll do... Okay, so actually what we're going to do is before we read it in, we have to know what's in the old data cell, right? So we're going to subtract what's in X0 from the accumulator, and then we're going to move P0 into X0, right? Oh, wait a second. Subtract X0, and then we need to store our current address. That's the only thing. Because when we read or write from the data line, it pops our address 1 over. So actually what we need to do is move X1 into the DAT, right? So that'll be our current address. Then we'll sub X0, move P0 into X0. So that's all we've done that. So now we need to move DAT into X1. So that's us rewound the value. So we read from it, which pops us ahead, and then we rewind by 1, and then we move data into it, and that pops us ahead. And then the other thing I need to do is test if DAT is equal to 7 because of course we're thing. And if it was 7, then it's now 8, in which case we need to move 0 into x1, and that will reset us to the start, right? So let's actually just advance this. Oh crap, reset, I need to sleep. Forgot about my sleep. Sleep 1. Okay, let's try this again. Advance. And my accumulator... Oh, you know what? That was really silly. So I'm subtracting, but I also need to add. So after all this, add P0 to the accumulator. Now, this might make more sense. Oh, there you see the number. So the accumulator is going up, and then it's now above 432, and we should have flipped this thing. Okay. So now. No. I'm just trying to think, where am I going to store the window state? Oh, actually, yeah, I just need to know. So I need to do the test here and then. So if I test if TGT accumulator is greater than 400, if it is, then move 0 to P1. Otherwise, move 100 to P1. And then we actually need to sleep down here, don't we? Okay. Advance. Window open. Windows closed. Window open. Okay. Simulate. Look at that window. Just waiting for the pollution to Oh! Oh man, what happened here? What exactly happened? So the window closed. The window closed late. So why did it close late? We're reading from this. So I wish I could step by step on this particular test run. Show wires. No, I don't need that. Show profile or hide profile. Oh, that's interesting. I forget how to do breakpoints in this. Why is this wrong here? It's greater than or equal to, so maybe it should be greater than... Let's do it 399. Maybe it's an off by 1 error. Simulate. Open, close, open, close, open. Ah, there, excellent. That's all it was. It was an off by 1 error put in to capture people like me that are doing it wrong. So actually, production cost, doing pretty well. Somebody is clearly smarter than me. Somebody is better than I'm fairly average, although I think my lines of code are clearly longer than it should be. Still, I may come back and optimize this, or I may forge on with new problems. Let's come back to the main menu to see what they say about things. Good. By the way, maybe you noticed that this is a sliding window algorithm for a sliding window. Do you think that is funny? Jay, yes I do. Yes, I do think that is funny, but that's because I am a nerd. I hope you guys are enjoying this because I found this quite funny. I'm Scott Manley. Fly safe. Okay, so I realized the obvious optimization was to instead have separate reading and writing sides, and that way the address pointers don't need to get reset every cycle. Also, this instruction here, I had 4 lines, and I can cut out a line by using the gen instruction, so hopefully this should make me a little more competitive and more happy to hold my head high. There we go, 9 instructions. I was at 10 lines of code. My power usage is down to, well, my best is 332, but apparently the gen instruction uses a bit more power, so different ways to optimize for this. One final optimization was that if you initialize the accumulator to minus 350, then once you get up to 50, or once you get above 400, this will contain 50, which will be the value at which this goes positive. And then, of course, if we have a NOT gate here, it will basically take any value less than 50 and convert it to 100, and any value greater than 50, it'll convert it to 0, so you'll get this output here, in theory, and it means, of course, you just need to move the accumulator out of here, and everything's a whole lot lighter, a whole lot easier, and I get my power usage down to 287, which I'm almost proud of at last.